Hello everyone, we are again back in our channel. So welcome to our channel Dev Skills, and today we'll be creating new microservices and using some of the advanced features. So this will be going to be a very exciting session, and we'll be doing live coding. So let's start straight into the coding and show I will show you where we were and what we have to build. So in the last session, this is the fourth session. In the first session, we created a microservice which was Hello World microservices, and then we added logging, tracing, and we created a product microservice as well, where we stored the product details, and we applied Swagger documentation to that. And then we are building further by applying various features like configuration, health check, fault tolerance, and then we'll also apply observability or telemetry, and then we will proceed further into even advanced features like JWT authentication and REST client. So let's see our services. So we have a payment and product service. So this is our product service, and in the product service we have various classes. So important classes is our Pojo class, which is about storing product, and there is ID, name, description and price for the product. Then we have the resource class. In the resource class we have various CRUD methods. So you see here we have this resource class is a application scope bean. It has path products, and then we have also added some description for this particular method. There is an open API or Swagger documentation, so it's really very easy to test it. We have some initialization. Right now we are not using database, but going forward we will also be using database. So I will show you how to add database, how to do caching, etc. In later sessions, but first we'll cover all the advanced features of microservices. So here we have get all products, get method where we will get list of products. Then we have CRUD operations, which is get product by ID, create product, update product and delete product. So to run this we have to go to terminal, and let me show you what this application looks like when it is run. So now I'm in the terminal. I will say new terminal, and I am in the root folder, but I should go inside the project folder. So our application is called e-commerce store. Now I am inside, and there is a pom.xml also. I have shared in detail in the previous sessions what is various configurations, product settings which we are using, project settings which we are using in pom.xml. So it contains all the dependencies, plugins. So we have ambient plugin for Open Liberty, which is going to build this application. We'll be running this as a loose application, which is kind of an exploded application, which we will be able to update on the fly, and we will be able to see code updates or configuration updates or any dependencies update without having to rebuild this application and without having to repackage this application. So now it is showing something about the release version, which is 17. So let me just check what's my Java version by giving the Java version command. So you see it's Java JDK 11. We can also switch the versions. So this is again part of the POM. Our target version is part of our configuration. So as we see that we have Java 11 installed, but we have in the settings of the POM Java 17, so we can change this. We can get the Java 17 instead. So what I will say is I will show you. I'm running on the code space, so I can do this by changing my dev configuration settings. So here I will see that okay, there is dev configuration. In this we'll add Java. I will add Java by SDK man, and then I'll say okay. So you see here dev configurations there. Then we can say just a minute, let me update this again. So here we have to modify, okay, but yeah, here we will use, so modify your active configuration, and in this we have got we have to select Java. So in this Java we will have Java via SDK main. Okay, then it says 16 selected. Okay, so we say Java is selected via SDK main. Then I click here. Okay, not sure what's happening right now. Little bit some glitch, maybe some maintenance is going on, so it's not kind of behaving as expected. So sometimes this is a problem with the cloud-based development environment. So let's just keep it like this. Maven as 11, the compiler source and compiler target as 11. Let's see if this gets built. Also SDK Java list Java will list me all the available versions here. So we can just copy. Okay, other way to quickly update the Java version is from this list I can choose what Java I would like to install. So I will go here, I will choose Java 17. Okay, so there are so many options from all the providers. Let's choose the one which is yeah, this one should be good. So okay, so I will end this. Now I will say SDK install Java. So I am choosing to install this version which is 17. Then we will switch it and see if this resolves the problem. Otherwise we will get back to Java 11. So here I have showed you in this dev container or code space how we can install any version of Java. Now we will have to switch to this version once the installing of this version is done. Okay, done repackaging, 100% progress completed, and now the final steps of installation is happening. And yes, it's asking to be set as default. I will say yes. Now I will say Java version just to verify it. Yes, so this is Java 17 available in our dev container. So this is the easiest way, fastest way to switch. Now I will switch and save it, and let's see if this builds are application. So I'll give the command again, which is ambient liberty dev, to build and run this application in the dev mode. It's downloading the dependencies. So it has looked into various configuration files. One of the configuration file is pom.xml. Then it looks into the server.xml file, where we have the configuration for Open Liberty server. Server.xml file is placed in the src main liberty config folder, and then pom.xml, as you know, is placed in always the root folder of your project. So now this port is running 50/50, is where we will be having our application running. I'm opening in the browser Open Liberty, so you see the server is running. Now to verify this, we go to our context root, and then API, then products. This will get the list of products. So let's see. Yeah, we got the list of 2 products returned as a JSON. So here we can, with browser only, verify the get methods. Post methods not possible to test via browser, but for post method, get put method or delete method, we have to use either Postman or curl tools like curl, and there are some REST client plugins, HTTP plugins also available in Visual Studio Code, but all these are very tedious to use. I didn't find them very comfortable. So as we have added the Swagger configuration, that means we have Swagger configuration available. That means I have specified Open API dependency in my pom.xml. I've also added the feature for Liberty configuration around Open API. You see here MP Open API, and I have also enabled in the resources meta inf microprofile configuration MP Open API scan equal to true. So what it will do is it will scan all the classes, and wherever there are annotations for microprofile Open API documentation, it will generate the documentation. So now let's use this to test our microservice. So here path is Open API UI. So I'll just run it. You see here it is giving me what all operations are available. So here some descriptions there. We have the product resource class, where we have CRUD operations for products, and you can have here different servers, test servers. Also, if you have deployed application to the cloud, you can do that configuration as well. There are a lot of features, but what we are interested is running the same application, but from this client, which is Open API or Swagger client. So here there is an option like try it out. So we have get API products. It's like Java doc for APIs. So we have the description, we have the endpoint details, and then description also provides what is the return type. So it says get all products, returns a list of all products. So short description, long description. Then there are parameters if they are required. Here in this particular API, there are no parameters. What is the media type which is accepted by the API. Then there are some samples also about what is the schema, how the list of products will look like. So I'll click on this try it out button. This will give me option to execute this API and test it out, play around with it. So it's not just the static documentation, it is a dynamic documentation where developers can play around, learn more about the API. So this is one of the best documentation tool. It is also very useful for testing applications. So you see here we have this list of products. Great. So here, as you see, we got 2 products here. This is what we have initialized our product list to. So this is executed and you get the response body also and response headers. So everything is there, and these are some different response options available. Now let's test some other API which is creating a new product. So I will again say try it out. So now my request body is editable, okay, and I have to update this in the request body. So ID I'll say 3, name of the product I'll say iPad, and then the description I'll say Apple iPad Pro. Now the price for this I'll keep it, we have used a double data type, so this is our request body. So there's no parameter, only request body. We will be executing it and we will get some response. So response is as you see, this response body 201 is returned, and these are the details, right? So this is about get, this is about the post method to create a new product. So you can verify this by running product resource. I will execute it again and check all the list of products so that we should see now 3 products rather than 2, which we saw last time. So now you see here Apple iPad is also available in the response JSON. Now let's update this product. So we will test the put method. In the put method we have the parameter which is ID, because which application which product we have to modify, we have to provide this. So I will say we will be modifying ID. So I clicked on the try it out button, then I put 3 as my ID where we would like to modify, and then here I'll keep Apple iPad, the description same, and then I'll keep Apple iPad Pro as the description. See, I have slightly modified the description. I have said Apple iPad, earlier it was iPad, and then the price I will increase it further by $100, so $8.99. Now I am executing this again, and let's see what's the output. So here you see the changes have been applied. So you have the name updated, and let's execute the list of all product, this operation. So here I have updated here. So here you see this is updated Apple iPad, and the price is also updated to $8.99. Finally we will do the delete execution. So when I call the delete method, again it will take a parameter which is again the ID. I'll say delete my recent product. So I'm trying it out this API again, and say 3 is the ID for which I want to delete the product, and I execute. So here you see we get product deleted 204. This is the response. Correct. So also there is other response which is 404 if some product does not exist. So let me execute this method again. Now product 3 does not execute, do not exist, which we can verify in the get products method. Executing it again, you see here again only 2 products are there, and if I put some ID which is not existing like 3 or for example 4 also, which was also not previously there, and we execute here is put method. Here we execute in the delete with say something ID like which does not exist, we should get the response saying that this does not exist. Error, response status is 404. So this is all about our implementation of REST API and how we can test it very easily with Swagger. So I have explained you about how we did it. So now coming back to our editor. Similarly, we also have the product payment service. So I can open another terminal, and I can run both the microservices simultaneously. So I will go to payment, and in this I have again pom.xml. So I will show you here in this payment, And let me show you again the pom.xml. We have compiler set as 17, and this time we are using another port because on the same port two services cannot run. So now I will again do the same command key, and I will say this is dev. Again I'll run it in dev mode. So here the only problem is when we run two applications on the dev mode, the debugging port, there will be conflict in the debugging port, but automatically OpenLiberty will identify that there is already the port is occupied, so it will take an alternate port. Right? Let's see if that happens. Okay. So we can open our application here. Again, we have made Swagger documentation for payment service as well. So we will see in the payment service we have only one method, which is authorized payment, so which is for processing the payment. We have the post method for authorized payment. So if I click on post, try it out and just say post. This is a simple service here. I have just created it just for demonstration purpose. We may put some request body as well, where we can enter the amount, credit card details, etc. To authorize the payment, etc. But that is straightforward now. Having done for product service, will focus into doing more advanced features rather than building the business logic. That definitely you'll be able to do. So coming to the code again, we have verified both these services are running and working as expected. Okay, so now coming to coding part. Okay, as you can see that we have, this is the pom.xml. What else is there? And we have the src. Src folder will have payment entity. We have payment detail, where we have some details. Then we have a service. Right now the service contains just a result, which is it prints out something in the console. So as you can see here, calling payment gateway API to process payment. So this is what it is printing. So these two lines, this is just for debugging purpose or verification purpose, and then we return this message saying that payment process successfully. So as you can see here, we have this request response body, payment process successfully. So now let's assume this is a long running process. So let me make this as a long running process. We'll add some thread.sleep so that means generally payment processing, what will happen is they will take some time. So we would like to have this method as asynchronous method. Right now the problem is it's not asynchronous method. If it is long running process, for example, if there is some processing happening in the bank, there are some external calls, it might take time, and your resources are stuck. So this could be a problem for a microservice, because you want high scalability. You will have hundreds of requests, so you can't wait because otherwise the latency will be too high and the experience which your users will get will be very bad. So we'll implement this as an asynchronous service. How I will do? So this is first feature of MicroProfile fault tolerance. So until now we were using just the Java EE or Jakarta EE features of building REST client, which is very straightforward, very easy. We created a Pojo class to store the entity, and then we created a resource class where we have the resource method. Correct? We could further break it up. Basically, we can create a repository class where we have the database operations, and we can have a service class. So a service class can contain with some business logic, and then resource class will have the logic for REST API. So now let's make it this service is asynchronous. So MicroProfile, as I said, fault tolerance provides various annotations using which you can make the service asynchronous, right? And there are annotations for other fault tolerance features also. So they are basically 6 fault tolerance features which I will be demonstrating. First one is asynchronous. So here there is a business case. As I said, the payment processing always will take time. So first we will make it a long running process. So let's see, simple. I would create a method which will be called simulate delay, and in that I will implement something like some interrupt exception handling will be required here, but yes, so implementation will be very easy. So I have a simulate delay. This could be a method, and in this this is an internal method. I'll just make it a private method, and it do not return anything. So we will just say we'll have to use the try catch block, and then thread dot sleep. Okay, we will add a delay of 5 seconds. Let's assume it takes 5 seconds. Now the payment gateways are very fast, so simulate a delay of 5 seconds, and this is our thread. And then if there is an exception like interrupted exception, okay, we can just handle this, right? So there could be some handling for it, right? So I have added this. So basically this makes this a long running process, a small long running process. So let's see now. We'll try to execute it again because as I said, we are running this in the dev mode. So OpenLiberty will automatically detect the changes in the code, and it will update on the fly the payment method. So you see here, as I saved my class, it has updated, right? It has done the hot deployment and have updated the service. So let's see. This is the payment process service. Last time it executed instantaneously. Now it should take around 5 seconds. So you see loading for long, right? It could be. Then you have the so this is this about payment processing. Okay, let me increase the delay. Let's say we want 15 second delay, right? Because this is also good. So now again it has updated it on the fly. Now it should take more longer, almost around 15 seconds. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So something like that, 15-second delay it took. Yes, so but payment has been processed successfully. Now as I said, we want to make this as a asynchronous method. So what we'll do is we will add annotation for asynchronous. So here just if we put an annotation saying that asynchronous this will be sufficient to make this service as an asynchronous service. Okay, so you see here we have asynchronous, but we have to add this to import this. So what we will do is I will say import. It should suggest that we want asynchronous because yeah, otherwise we will get the compilation error. So here so for this import we will have to use okay, so the path will be org.eclipse.microprofile as we have for open API, and but here we have the standard fault tolerance, and then we should have asynchronous, right? This is the annotation. Now source compilation should succeed, and now this has become an asynchronous method. So now if we call this service, we should get the response faster, and payment processing should take faster. So basically it should run asynchronously. But yes, here there are some more changes which might be required here. So when we make something asynchronous, so you don't get the response immediately. So we will have to use something called there is completion state, and then we have to make this as a response, right? And in the return, so what we have to do is we have to wrap this entire thing within something like so we have to wrap this within yeah, so something like this. So you have some simulate delay, then we have some example logic, okay, exactly the same thing. So here we have simulate delay, then example logic, and okay, so same thing what was there earlier. I'm just kind of preserving my yes, so okay, and then dummy response. So now we don't need this, so we can remove it, and we don't need a return. No, we need a return. So this is how the new implementation, which is asynchronous implementation, will become. Okay. So let me save this. Now again, completion stage has to be imported. So let me import two classes we have to import. One is completable future, which is an implementation of completion stage. So completion stage is parent class, and this is computable future. Completable feature. Future is the implementation. So I will import this. So now to import, this is coming from java.util, standard Java feature dot, here we have to say completion stage. Okay, and then same we will have completable future. So here we have now everything implemented. So see the now here the compilation successful, payment is up to date, right? Up to date. So let's see if this demonstrates this execution in a asynchronous way, right? Because the processing completion will take the same time, but it will be more responsive. So how do we demonstrate that is what I'm thinking about. So here it's taking time to execute it, but it is now this time executing in the background thread as an asynchronous process. So let's see how I can kind of demonstrate asynchronous execution. So what I'm thinking of, maybe we will put some message saying that payment processing is happening, and if we see that message, okay. So here this message calling payment gateway API, this is coming from here. Okay, so yeah, what we can do is we can have some message here which is right. So received the request to process payment, right? So as you all know that if I would have executed it without asynchronous, entire thing okay. So what we could also do is uh, we can add something like this, then apply. So system processing completed. Yeah. So here let's see what happens. I go back here, I execute this method, immediately received request to process payment is received, then the processing is happening in the background, and it is a long running process. Now it's successfully completed, and then you have this message, payment processing completed, right? So this is a demonstration of that this is asynchronous method. Okay, now next is let's talk about retry. So if the payment attempts fail, then how do we implement retry mechanism, right? Retry mechanism we could have implemented even without asynchronous messaging, without asynchronous, not messaging, this is asynchronous execution. So let's say we have to implement because now if we have the matrices for this then we will be able to track the number of executions, right? Correct. So first let me add simple log messages just to kind of demonstrate that the retry mechanism is happening, right? So here for implementing retry, what we have to do is we have to add an annotation retry. This is max retries equal to 3 and delay is equal to 1000. So we have put like, okay, there will be immediately we should not retry because we should give some time for the system to recover, right? Now retry has these two parameters. We should also have this added in import statement. So now retry is implemented. So basically there are three things. One is I'm just organizing the imports so that becomes more maintainable. Okay. So yeah, here this is implemented. There is another feature called jitter because if there is multiple things failing in the system, we should have some random delay after each retries, right? So now I have added jitter as well. Now we should add some delay, some failures. So if we simulate a failure, we can simulate a failure by just putting some random condition. So what will happen is we have 50% failure chances. It's so simulated failure occurred, simulated payment processing failure, right? So some details I've added here. Now if I run this application, run this service, let's see what happens. It's a long running process, receiving payment processing. I think it will complete. I will reduce the delay also here to 5 seconds because so that I can demonstrate the delay faster. Okay, so okay, I can increase the failure percentage also. Let's say we increase it to 0.8 so that it can retry and we will have higher chances of failures. Okay. Okay, payment process successfully. Let's see what's there in the it processed. Let me call again. So it's say receiving request to process payment. Payment processing happened successfully. So simulated failure, there's less chances of simulated failure now. Sorry, so it should be lower number 0.2 to have more failures. So here because we are using greater than, right? Now we will see received request to process the payment. So now there is some failure, payment processing failure. So there is an error. Okay, so let's say yeah, this is asynchronous, but with the retry this seems to be, we should not have this asynchronous state. So let me put this back so that we can demonstrate retries. We have seen how the asynchronous works. We could have done this in the other service, which is the product service, get products, right? You assume the database is down, or the service which is giving the inventory is down, and then it will recover from it, right? So then this will have to be made as a response. So these are older implementation where we didn't add anything for asynchronous. Okay, so now I execute this. So here it is executing, and let's see what happens. I'm stopping the server, starting it again. Okay. So now service is running. We'll call this service. So received request to process payment. There's a delay 5 seconds. There is a processing failure. Okay, so it ends in the error stage. Rather than having this simulated error, I'll use some other mechanism to demonstrate it, which could be related to matrices, right? Because here I'm throwing a new error. Let's not throw this error, and then check this, because yeah, in actual implementation you will have some error, but let's assume so simulated failure occurred. So it should retry after every 1 second, and then it should complete the execution, right? So you see here, second attempt is successful. So we should get a printed message saying that, yeah, let's say here I'll put another message. Earlier we had that payment processing complete, so we can put here, rather than processing So here this is a good way to demonstrate it. Service is updated. Now I will make a call. Receive request to process payment. So payment processing completed. So this time in the first attempt only it got completed. So now received request to process payment. Okay, again got completed. Simulated failure is not happening. Now simulated error is happening, and then payment processing got completed. So yes, in spite of failure, this again will not interrupt the flow. Yes. So we should use some exception which is internal exception rather than some external exception. I'll take a short break for a few seconds, then we will come back. Okay, so now I'm back. So we'll look into the MicroProfile documentation for Open API, for fault tolerance, so that I will see what other fault tolerance features are there, and then we'll implement it. Right? As I said, there are 6. One is asynchronous, which I demonstrated. Then we looked into the retry. Then there is a fallback. Then there's a feature called circuit breaker, and there is bulkhead. So these are various mechanism for fault tolerance which is available in MicroProfile, and these are fairly good patterns, most popular patterns for fault tolerance in microservices. So yeah, I'm going to MicroProfile and fault tolerance. Fault tolerance is the chapter 8. Yeah, I'm coming back. Yes, so images and all, and fault tolerance. So circuit breaker and all that I will explain in detail. So here this is a very good documentation written by me. I wrote it few months back, so that's why I'm referring, because various strategies, asynchronous execution. I'll put the link to this documentation in the description so that you can also look into it. And this will also be published in site soon. So we see asynchronous execution. Then next thing is the timeout. Timeout is if there is long running process and you want to timeout, then this is used. Retry, bulkhead, and fallback. And circuit breaker is also there. So if there are more number of errors, then we can temporarily make the application down, so that we don't get into more worse situation. And once the service recovers back, then we kind of put it back, right? So this is about various annotations which are available. They are very easy to implement. So you see here, this is an example of how we can implement retries. So let's put this uh, right. Let's put this into our application. Okay. So let's see. I will update the code. So basically, we will have to create two exceptions. One exception will be a retryable exception. If some temporary error is there, then it makes sense to retry. So in the previous demonstration, what mistake we did was we were using runtime exception, and which may not be a temporary exception, right? So if there are some crash which cannot be recovered, unrecoverable errors, then doesn't make sense to have retries. Retries only make sense if you have something which is recoverable, right? So let me put this code which we used for demonstration purpose again. Yes, so I'm just updating the code. So you see here we have asynchronous. This processing is asynchronous. Then there is a retries, and we have some exceptions also, right? And we will be throwing this exception. And in some rare situation, we can have a critical payment exception. So let's say we have 50% chances of payment processing exception. Okay, so let's add the condition for critical payment condition, critical payment exception as well. So one is recoverable error, other one is unrecoverable error. So we'll put a condition that if the mat.random is the value is random value is some less chances, very rare situation, but yeah. So let's see what's this error all about. Okay, return is computable future response. So let me put back so we have the completion stage response, we have retry, we have computable future async, and within this we have simulated delay. Okay, simulated delay. And then we have return response, and then we have this apply, but somehow it's giving some error. Okay, actually this was some syntax error, some typo. We could fix it in some. Okay, yeah, so now this is fixed. So basically you have retry, you have simulated delay, you will call, and if some random value is critical payment exception, otherwise there is a simulated failure which is simple failure. This is recoverable and this is non-recoverable, right? So let me put here, and this is recoverable. Okay, so this is applied, and then we have the exception classes also, right? We should have public classes so that we can reuse within other services also, or yeah, if it is only required within this plus class, then we can have this class included in the same file. But yes, just for demonstration purpose, not a production ready code, so this should be good. Now I'm executing this. Let's see what's happening. So here, received a request to process payment. There is a failure, critical pay failure, so no retries will happen, and we should get some error here, error payment processing failed, which is good. Let's say now I retry again. So let's see what happens here. Now received, now it completed because no failures were reported. Okay, let me try again. No failures. Okay, again. So non critical failure. So there is an exception, so retry should happen and it should recover, but did that. So let me make this non-asynchronous, so that now you don't need in this case. In exceptional cases, I'll put okay. Let's see what happened. no failures. So yeah, basically you should understand that these are the various parameters which we can apply to the retry mechanism, which is delay, jitter, retry on, abort on, and this way you can make your service more reliable. So in case of failures as well, you will be able to retry, right? So now let's talk about observability. Other other scenarios we can implement going forward, but for the time being, we'll pause here and we will look into traceability. Telemetry. So another feature which we want to build is telemetry. So a few minutes we will be putting up code for telemetry. Okay, so we will be looking into distributed tracing, because basically the scenario is that in microservices, you will have execution which is across multiple instances or servers. It's hard to have correlated logs. So in this part of the session, we will be discussing about how to implement distributed tracing, which is also very important feature or pattern for making your microservices more reliable. So basically we have a concept of spans and traces. So trace is a collection of related span, and span is basic unit of tracing. So basically one message is called span, and their span generally will have operation name. Say for example, process payment is an operation. It will have start date and duration, and it will have various other attributes like who is the user, who has requested this processing, any other details like HTTPS status code, resources. You can have some data, and then you have the parent span also, because it is in a hierarchy, because you might have various events, associated events. So we have this hierarchy of spans, and through one end-to-end execution, if you see one end-to-end execution, this collection is called as trace. So basically you get a tree structure, and you see context propagation means they have context process propagation. So your metadata information is not lost and is available in all the trace messages. So now let's instrument our service to have this open telemetry as well. So now to implement open telemetry, right, so we should So basically first step would be to implement the feature, to add the feature. So first thing is in the pom.xml we should have the required dependencies. So I go to pom.xml, and in pom.xml let's look into the dependencies. We have the entire microprofile dependency available, so fault tolerance will be included, right? If you just want to use fault tolerance or telemetry, we could just use the open telemetry. Then what we have to do is in the payment service we have to create a span. So let's say, how do we create a span? We put the code. So I will come back to the payment service. So when your payment processing is start, we will create a span, right? So let me make this more aligned, indentation proper. So process payment, this is the start of the span. So then you have received payment request, then calling the payment gateway API could be there, right? Then you have various conditions for exceptions, and then you have ending of span also. So here we can just say that we have the span which is ending, which should be just before we return, right? So span dot end. Okay, and then we should also record exceptions. So wherever we are catching the exceptions, we can say, for example, this interrupt exception is fine, but in case of other exceptions, we can say that so here we have throw new exception, and when we are catching this, we will have this method. Let me come back after a short break, then we'll continue again. So yes, I'm back. So let me apply the changes to have the tracing enabled. So as you can see, I have created a tracer. Tracer is a collection of spans, and we have the various import statements, and then we have various exceptions. We are handling all these exceptions, and yes, so let's execute this. If there are any errors, let me see if we can fix it. So it's saying tracer cannot find. Let me try to rerun this. Because as such the editor is not showing any error. This Visual Studio Code running online in GitHub Codespaces. So I'm still in work for open tracing. So I'll connect back with the open telemetry little later. But in this session, we saw that okay, how we applied various fault tolerance mechanism, basically the retry and asynchronous execution. Pretty simple and straightforward. Our timeout. Timeout also just specify the time for the delay, and then in detail we'll cover about bulkhead and circuit breaker in coming session. But for today, that's it. Thank you.